on the air.
All right, very good. Well, good evening, everybody, and good morning, good afternoon, and good evening to everybody out there in television land. I hope the rain had stopped in New Jersey. I understand it was not quite the pretty picture in Somerset and Middlesex counties. Our old stomping grounds at the South Plains Rescue Squad was hit pretty hard yesterday, so sorry to hear. So I'm coming to you live from Marco Island, Florida. I have the Gulf of Mexico to my left over here. We got here on Saturday, and this is part of an adventure where we took down the auto train, and then we're going to make multiple stops on the way home, and so we should be back before the end of the month. So anyway, so yes, thanks for coming out for whoever's out there in person. Of course, you have pizza and soft drinks, as we always do. So as you see here is the QR code to sign in. Please do so. But I'm going to go to the front screen. And so what I'm going to do is do the same thing as last week. I'm going to do a couple of the slides that I normally would do at the end of the meeting. All right. So, all right. So our usual agenda is to thank our sponsors, talk about what's new. I'll introduce Joe. And then before he gets into his main presentation, I'll talk about what's coming up for us and some upcoming events. And you guys can look at the slides on your own for some of the other things. All right, so our gold sponsor is Payara. They're makers of the Payara platform, which includes Payara Enterprise, Payara Micro, Payara Community, Payara Service. They also have their Payara Cloud and the new Payara Cube, where you can actually have all the stuff that Kubernetes will handle, but they abstract that for you. And at the virtual Payara conference last week, I even asked the question, do you have to write your own app.yaml file? And the answer is no, you do not. So I look forward to learning about this, and perhaps we can have a presentation on that sometime down the road. So good stuff coming from the Payara folks. Our silver sponsor is Azul, makers of their own downstream distribution of the OpenJDK. We are partnered with DevNexus, and of course, for those of you who come on a regular basis, I always crow about how great this conference is, and the fact that Barry and myself and Chandra and some of the other folks have been honored to speak at the conference. So they are our partners, and that's run by the Atlanta Jug. Our meeting sponsors, JetBrains, of course, they provide the one-year licenses to IntelliJ IDEA. The Jakarta EE folks offer Crowdcast hosting for any of the Java user groups, and we used to use them, but we decided to go with the live streaming to YouTube. We also have Romanelli's, the local pizza parlor right around the corner, essentially, from us, and also Nikki's Firehouse pizza store just not too far away from there. All right, our memberships, as you all know, the Microprofile Working Group, the Jakarta EE Working Group, the Jakarta EE Ambassadors. So we advocate for the Jakarta EE platform, and of course, the Virtual Jug. Payara started working with Java user groups at the beginning of the year, and they've had their Spotlight podcast, and they've had 4, and we were actually honored to have been the first one. So these are links to all of those podcasts that, in case you're interested in what some of the other groups are doing. And let's see, what's new? Let me make sure I didn't miss anything. Okay. I mentioned this last week. I want to mention it again. Some of the speakers more recently have been sending me their slides in some way, shape, or form. And so instead of sending it via email to everybody, I thought I would add a little section. And if you can see my cursor, but right there in the middle, you see the little icons. I updated this, Billy's link to his testing presentation from last week. And this is all under the resources endpoint from our website. This Pyara Cube, I mentioned this last week, and you can check out what's available there. Again, I'll try to find out more, maybe hopefully get my own demo account like I do Pyara Cloud, and we can try to experiment with that. And then Pyara and Azul partnered up together to do their Pyara Cube and the Azul Platform Prime. Both of these are subscription services, so this is something maybe your company would be interested in investing. Ramp down phase 2 should be this week. I forgot to add this. We actually have one JEP added, targeted for JDK 26, and that's the one that permanently disables or removes the applet API. That's kind of a sad day, because we all love those little applets from 25, 30 years ago, right? With Duke, doing his cartwheels and all that. So, but that's JDK 26 in March. This is 25 coming up in September. So those are the JEPs. The release schedule, yes, the 17th, so this Thursday. That should be announced by Mark Reinhold over at Oracle. I mentioned this last week too. Jakarta EE11 was formally released at the end of last month. A lot of work is underway for Jakarta EE12, and most of you have seen this already, right? These are all the new specifications or updates, 24 of them. And I'll get back to Joe in a minute. Upcoming events, the JVM Language Summit is in Santa Clara, California this year. It's been in New York in the past. And the Kansas City Developer Conference is in mid-August. We get a 10% discount. The Jalapeno Unconference, it dawned on me early this morning that, hey, I should add this on the list. And this is in Puerto Morelos, Mexico. It's kind of funny. If you click on this link, the URL is jalapeno with the tilde over the n .net. But it's funny when you copy and paste it, that's what it came out. So, so in case you're anybody would like to spend a couple of days in Mexico, you can do that in mid-September. At the end of September is Dev2 Next, and I think Vlad, if he's there, I think he won the free ticket with the raffle. I just found this out either yesterday morning or this morning. So if you're there, Vlad, congratulations. You got a free ticket for Dev2 Next. If you don't win a free ticket, there's a $50 discount. What else we got? The JCon at IBM Tech Exchange, and this is in Orlando, Florida, which is about 4 hours away from where I am now. We also get a 30% discount. The InfoQ Dev Summit Munich is in mid-October in Munich, Germany. Let's see, what else? QCon San Francisco in mid-November. And then QCon AI New York is in mid-December. And what's coming up for us, so at the moment, we almost had Venkat visit with us next month, but as it turned out, his visit with his customer was sooner rather than later. So, I told him, of course, the door is open anytime. Whenever you're here, we'll make room, So, so right now, as it stands, our next meeting is on September 9th, and we have 2 presentations. Vlad, who I just mentioned, will talk about Apache Spark and Databricks. And Alok will talk about Java applications with LangChain 4J. Then we have some of the stuff that's already happened. You saw this last week. So July 17th. Okay, so Kansas City Jug, Atlanta Jug have their meetings, Chicago and Philly, and the Boston folks. So Dimitri's going to be there. If you remember, he came, visited with us last year in August, and that was a great presentation. So, all right, so enough of me. I'm going to introduce Joe right now. And Joe, I'm just going to read your bio as I have it, if that's okay. So Joe Sherwin is a principal solution architect at Hazelcast with 22 years of experience in the design, development, and implementation of application systems within multi-tier distributed computing environments. Working with clients such as Vanguard, Fannie Mae, Federal Reserve Bank, Citigroup, Bear Stearns, Fixed Income Clearing Corporation, Comcast, Webster Bank, Gartner Group, Hartford Life Company, IBM Global Services, Mass Mutual, the list goes on and on. Joe, you've been a busy guy, I tell you. So Mr. Sherman has been instrumental in the development of large-scale, mission-critical e-commerce, insurance, and financial systems. He has experience architecting and implementing solutions using Corba, RMI, remote method invocation, Java EE compliant distributed object architectures, in-memory high transaction low latency solutions using Hazelcast in-memory data grid, Gemfire, eCache, Oracle coherence, and solutions deployable on infrastructure as a service or platform as a service like Cloud Foundry, Amazon Web Services, Rackspace, or Heroku. So first of all, Joe, sorry I couldn't be there. This was something we had planned for quite some time. We need to make these reservations 20 months in advance. So we already have booked for 2026, believe it or not. So, yeah. But we love it down here. It's a great way to spend a week on the beach. And you still feel like you've worked in the yard for 5 hours, even though we don't do a damn thing. But first of all, I'm gonna sign off. Again, sorry I couldn't be there, meet you in person. Perhaps our paths will cross someday. That would be awesome.
Thank you, Mike.
So with that, Joe, the floor is yours, and have a good meeting.
Thank you. Appreciate it.
Oh, I got a section.
You can just close Zoom now.
Ooh. Well, obviously it's pre-2008. But Merrill Lynch was the savior there, I guess. So you guys heard my bio. How about everyone introducing themselves? I think we have enough people here. You want to go first?
For me? Yeah. My name is Boris Minkin. I'm been a Java developer for a very long time, working with for a major credit card processing company.
Just speak up when you're introducing yourself.
Okay.
Hey. Rick Polshuk, Java user for close to 30 years.
So you on board early?
1.1, I think.
Yeah.
And I've worked mostly in the financial world, and now me, my two daughters, and a fourth man have our own mobile phone app we're working on, and the back end is a Java website.
Oh boy. Introduce yourself. Oh. Okay, here we go.
Moshe, I'm actually a photographer, but been programming since '76. Basic when I first started. Wow. Just an avid hobbyist.
Cool. And?
I'm Gary Lepselter. I'm a global account manager working with Joe on sales to large banks mostly.
All right.
Yeah, good stuff.
Speak up. Speak up.
Trey King. I'm a vice president of strategic sales at Hazelcast. Been in the caching space for gosh, almost 13 years now. So worked with Joe for a few years, even in a prior life. So yeah, nice to meet everyone.
All right. Who's next? Go ahead.
I'm Carl.
I'll catch you.
I've been working on.
Speak up, Carl.
Yeah. I've been working on web applications for 7 years. I don't really have a background in Java, but I just thought it would be like productive to go to some meetups like this.
Sounds good to me. All right.
Hey all, Jordi Hernandez. I'm an IT specialist with the New Jersey Department of the Treasury. Full disclosure, I'm on my own capacity, not with the state. And of course, I have used Java when I was in college, but I'm also hoping to use Java in a bigger scale when it comes to like personal projects or other things down the road.
All right, Big Bill.
I'm Bill Brutzman. I am an IT guy at a manufacturing company in Bergen County.
IT guy.
An IT guy. And you are?
Hi, I'm Rahul Prasad, and I'm a Java developer at a financial services company.
Cool. Where are we? Here we go. Yeah.
Me?
Yep, yell.
I'm Marina and working mostly with startups, and I'm product owner.
Okay.
Yeah, my name is Vladimir. I'm software engineer, Java, Kotlin, Golang, microservices, backend mostly.
Got it. And
My name is Paul. I've been doing Java for many years. Just when I was in college, someone came up to me saying, Java is the greatest next thing. There was no Java at the time. And a few years later, I started becoming a Java developer in Japan, and I've done applis and worked for insurance, now with banks and financial and stuff, and doing other stuff too.
cool. And here's another Paul.
Yeah, Paul. I've been in IT for a number of years, of course, and I've been director of this great Java user group for a while here now, so we're moving ahead.
And I'm Barry. I'm another director of the group and an imposter in many ways.
Yeah, it's nice meeting everyone. As you can see, there's a lot of wisdom in the room when it comes to the history of Java.
Now, right now, we're seeing your presenter view. I don't know if you want to fix
Yeah,
that.
I do want to fix that. Thank you.
He says top left. There you go.
There you go.
Okay.
So yeah, we have a lot of wisdom in the room. Java's 30 years in a couple of weeks now. But one of the things we're going to talk about here is actually microservices, which is independent of the languages, but most of the code I'm going to show you is implemented in Java for our demo sessions. And what we really want to talk about is, so a lot of companies, you guys must know, modernization, moving applications from traditional infrastructure to the cloud is like the most important things for a lot of the IT objectives that are going around these large organizations, especially the larger ones. I mean, if you're working for a startup or a smaller company, you probably start with a modern environment. But this also applies. So what we're looking at is what really is the what's the microservices architecture, and I'm going to need a lot of participation from the audience. I'd appreciate that. We're going to look at the advantage of the microservices architecture, the disadvantages, and we're going to talk about how we can overcome some of these disadvantages. And when we look deeper in the advantages, there are some things that are kind of assumed about the microservices architecture, and we will talk about that as well. I'm going to ask, anybody wants to say what microservices is to them, or what do they think it is?
There you go.
I think it's APIs instead of a big monolithic legacy dynasty.
Exactly. Yeah. So yeah.
Really, what it's in the name. It's smaller components that come together to provide even more complex behavior in a system, functionality.
Makes it easier to write, but you get less performance.
Exactly.
So it's easier to write. You can apply the agile methods easier to microservices. Correct. So, and
I was reading the article earlier this year. It's called modular monolith versus microservices or something, and there was argument there that in many cases, modular monolith might be better than a bunch of microservices because of the performance issues.
Yes, you're right. So if first of all, if you wrote your monolith in the modular framework, you'll probably have a better chance of moving your application to a cloud-based or microservice type architecture. Yeah. So good practices in architecture allows your solution to have a longer life.
Just a quick question. What is your perspective on microservices with REST API or with messaging? Given the choice, what would you use if you had both?
Oh, so yeah,
So I work with systems that do both. Okay, so a payment system, for example. Payment systems, sometimes you need payments to have a transactional API, a session. And other times you just need to be able to send a batch of payment requests, ACH, whatever it might be. And then you just need a messaging interface to do that. But yeah, it all depends on the use case. The number of clients also might play into that. So if you don't want to maintain a session and you can do compensating transaction, you may just do messaging only, right? So that limits the amount of sockets that's opened on that tier of your gateway, your payment gateway. So I work for Hazelcast. So Hazelcast is involved in a lot of those types of use cases. My job is to help the Hazelcast customers to design applications using the product, but also design applications well, in spite of what products they use. And what's Michael earlier in his introduction talked about your sponsor Payara. Hazelcast is a clustering mechanism for Payara. Just if you don't know the history of Hazelcast, has anyone heard of Hazelcast before? Yes. Okay, we're gonna have to do a better job.
Yeah, there we go.
He knows Tilly, which is
you know the name of the other two for bonus points? The other two founders?
Fouad?
Yeah, Fouad. What was the third one, Joe?
Oh, Ennis.
Yeah, Ennis Carr.
Ennis was a great guy. He was a mentor.
We're using a free competitor of Payara, which is JHipster.
JHipster, I know.
It also defaults to Hazelcast. Yes.
Not enough.
Yeah, it depends on
what you want to do with it.
No, it doesn't default to.
I had to choose it. We're in the.
Yeah, that's right. When you go down the list, yes, you have.
It's not the default.
Yes, it's not the default. It's on the list. And most people choose Hazelcast using JHipster.
I had to switch to it.
Yeah. Why did you switch to it?
Because the other one wasn't working.
Which one was that?
Yeah, I'm not going to do that.
But Hazelcast is working well for you.
Yes.
We'll get a little further. So the
advantages of Hazelcast, of microservices, right? We've said a couple: modularity, decoupling, isolation. So when you isolate into a single function, any kind of errors is also isolated to a single microservice, right? Independent deployment, so you can work much better as far as life cycle processes in your development process. Scalability, we'll talk about that, but technology diversity. So like I was saying, microservice doesn't have to be implemented in Java. The service that I'm calling doesn't have to be implemented with Java. So then again, this is why the REST API is important, right? It's ubiquitous. Anyone can call a curl command, right? And again, increased developer velocity. You have a narrower scope of what you're working on. You're able to use the agile method much more effectively when you take the microservices approach to developing systems. Now, I have question marks on advantages because some of the these advantages assume a lot. So scalability, for example, because you typically run the microservice in an infrastructure that's horizontally scalable, it doesn't necessarily mean that your microservice and what it's doing is horizontally scalable, right? It just means that I have more resources available so the next request can go to another instance of my microservice. But whatever my microservice is doing, it's going to take X number of inputs, and it's going to be limited to what it can do in terms of data, in terms of compute. If I'm calculating pi, and one request to calculate pi may take up all my system resources, right? So it doesn't necessarily scale that compute across multiple virtual compute nodes. Now, fault tolerance is another one. You have to have infrastructure involved in order for your microservice to be fault tolerant. And most likely what that means, you're restarting your process. So if I make a request and it goes to instance A to calculate pi and it's not responding, there might be a smart load balancer in between my requests is saying, okay, after this timeout, I need to send him to another instance. So there's some sort of infrastructure that needs to be in place in order for you to gain that fault tolerance. And sometimes that fault tolerance might mean another data center or another region in the cloud. So there are advantages to traditional architectures, but there are the devil is in the details. So now we go to the disadvantages, right? Someone said it right off the bat, increased complexity, right? When I have a microservice for every function in a system, now how do I cobble all that together? How do they communicate with each other? Inter-process communication, which is, again, if you're in computer science, you know that that's a classic use case. If you've used semaphores even on a single machine to coordinate multiple processes or share data with multiple processes, you've encountered inter-process communication, inter-service communication. Latency. So now if I need to call another microservice to do something for me, now I'm increasing latency into my solution. Eventual consistency. Again, state. The best microservice out there is the ones that are stateless, but we know that not all solutions are stateless. The more interesting ones are stateful. So being able to share a consistent view of state between multiple instances of a single microservice or even different sets of microservices. And again, the scalability and performance part of it. So latency, again, affects performance. What your microservice is actually doing, even with a single request, how does the microservice improve or scale out the ability to do that compute? So developer velocity also is impacted because of how, when you start talking about state and accessing data stores, your microservice may decide, typically what people do with a microservice in order to overcome some of these latency issues is do a caching pattern. And they check the cache, it's not there, their microservice goes out to a system of record. So now you're increasing complexity and you're increasing the velocity of your developers. Any questions and remarks about these?
I would argue.
Go ahead.
I would argue that microservices makes it more scalable with lower performance.
Yeah, that's true.
Because, I mean, scalability does not mean fast. It means you can have more users at the same speed.
Yeah, right. Well, you can have more users, but what you end up doing, the way microservices are scaled, is using more infrastructure.
Yes.
It gets monitoring and managing a lot more complicated also, or something.
Yeah, thank you.
But because you don't have state, that impacts performance.
Yeah, that's a great point. Two great points.
Do you think there should be like an upper limit to the number of microservices you can have, like 20 or 50, or like what's the most you've seen so far?
I've seen
quite. See, this is the scale issue for me. When I look at systems, they're scaling their microservices unnecessarily all the time. And what happens is the bank says, "Oh, we're going to use our public cloud vendor," and then they get the bill later. And then they go, "Oh, well, what's happening here?" And it turns out, when you do a lot of compute inside of a microservice, you end up scaling the microservice not because of the number of requests, but the resources it's pinning while it's doing that compute. So you can't really gain. What to gain with that scalability that you argued for is, or what the negative of that scalability is the cost that's going to incur. So unlimited amount of funds, sure, yeah, scaling. I got 10,000 people calculating pi, I can have 10,000 instances of my microservice.
I really agree with the increased complexity, because to me, you could have one or two people work on a microservice versus, if there are 10 people on the team, not everybody has to know every part of the code. And likewise, if someone new comes along, if they just focus on that microservice and it's well written and it's a spec, then to me it's less complexity.
You're absolutely right. That is the advantage of
microservices approach. The complexity we're talking about here is when you have to communicate with each other, when you have to use multiple microservices to get something done. But yes, from a developer point of view, the microservices architecture is a lot simpler to deal with.
But maybe not from the architecture point of view.
Not from the architectural point
of view, or the system level of the issues. Yeah. Do you have a rebuttal, or?
I know I can't read anybody else's code. I can read my code fine, and I go to some pains to make it clear, and I indent, and I use meaningful variable names.
Oh, yeah,
and I like to think if I look at it later, I'll be able to figure out what it is quickly. But other, big legacy stuff, it's like I got to start from scratch with the whole thing anyway. So.
Yeah. I
totally. And yes, you're right. If you deal with a microservice, and if your system is, the boundaries is defined properly, it does simplify development, and it does give developers more of a single-mindedness when they have to accomplish a task. It makes it more atomic. So there is a productivity gain from this architecture style. Yeah. But then also things that's lost in the architecture style that's not addressed very well. So, we talk about working with data in motion. We talk about messaging. Messaging is data in motion, event processing, event-driven solutions, near real-time processing, geo-replication of state. So can I see the same state in the West Coast that I see in the East Coast? And what's the latency between that? Yeah. So those kinds of more complex use cases, it's not addressed in the microservices architecture for good reason. But when you're working with really large corporations, when you're working with people who are interested in having geographical distribution of their applications, composable architectures that they can deploy anywhere in the world. Those things become quite important, sharing state between different systems that are geographically dispersed. And it's also important in disaster recovery as well. So one of the solutions that that's first used in microservices is caching, and that solution becomes very obvious right away when you're using the microservice architecture and you're deploying in the cloud that latency is going to be your issue. So one of the first approaches to solving that is using caching, whether it's local cache or some fancy implementation of the map from Google. You're gonna use caching in order to solve those problems. Everything's slower in the cloud. They didn't tell you that. It's scalable, but it's slower. So simple caching is not enough when it comes to dealing with these disadvantages. What we have typically is solutions to address storage, and storage in memory is typically the way to limit data access latency. Compute, so you're taking that data that you've stored and you're doing compute on it, right? I'm calculating the average of the accounts over 50 grand, or the average of the accounts that have a certain limit in terms of usage or permission rights and things like that they can do with requests to a system. So computing, we don't just store data just to store data, to send it back and forth to an application. We're actually doing compute on the data, right? Even if you have a mobile application, you may not want your mobile device doing compute on a giant set of data. You may want to do that pre-computing in your microservices level, typically is where people are doing it, and then they're sending the results on. We talk about messaging, the ability to have not just a messaging structure for your microservice to communicate with the client. You can use messaging. You want to use messaging when you have multiple instances of a microservice to let each other know, hey, guess what, this has happened, or signaling, right? So if you can combine all those capabilities together into one product, what you end up getting is a product like Hazelcast, right? And using Hazelcast to solve some of these difficult disadvantages is really what we're going to talk about. Oops. So latency, we all know what latency is, I hope. We'll have to go through this, but measuring success in thousands of seconds. I say thousands of seconds. And forcing your bottleneck down to the network. The key thing here, though, is ultra low latency networks will expose your server-side application latency. So you see this I see this all the time, where an application team is blaming the network, and the network team is blaming the application team, and no one can really understand why the application is slow. So being able to truly push the blame onto the network is a key thing, and not all applications are implemented in a way they can do that. So what we see in microservices is a lot of data shuffling. So getting a set of records, whether it's from a cache in memory or from a database. Yeah, just because it's memory doesn't mean your service is fast. Because what is your what does that, what do you have to do with that data? If it's not local to you, you have to put it across the wire. And if you're grabbing a big set of it so that you can crunch through it and do that computation, that analytics, and spit out the answer, then your server side is the culprit in that situation.
Is the hard problem latency?
The talk is solving the hard problem. Is latency the biggest part of the hard problem?
Yeah, so
The hard problem is latency, and the hard problem is true scalability and distributed computing. So yeah, so getting the most out of your microservice is solving those problems, yes. And again, to understand the importance of latency, if you're familiar with the time delay between deep space probes or faraway planets, brain controlling your body, you see something, you're crossing the street, you see a car, you know, how fast can you react? Athletic reflexes is what you want to give your applications.
That's what latency is as well.
Controlling my brain.
Brian.
But so
What?
Brian can't spell.
Brian can't spell. Brian is dependent on the computer too much. So the old way, right? So this is how microservices usually do it, right? And the new way Hazelcast is proposing. We compare and contrast those. So in the old way, your microservice, your client, pull the data out of the database with a get entry. You get data returned to you, and then you put data, okay? You can see the number of steps, and every step that in that process is latency, okay? What Hazelcast is saying is, oh, instead of you asking for data that you have to go compute and then send data again, why don't you tell a cluster of computers to distribute this calculation where the data is living and send me the answer, and I'll just forward it to the caller. Now, making that possible is what Hazelcast is all about, and solving those very difficult problems of scalability and latency. Let's take a quick look. So here I have a products microservice, okay? In Hazelcast, data is sharded across members of a cluster, okay? I can also listen to changes to data. Data is never static, okay? They all have a different amount of timeline, but it's never static. So if there's a change, maybe some other microservice is changing data, maybe some legacy application is changing data, I can listen to that change. I can listen to specific product ranges. So I can say, you know what, I'm only interested in products A to G. Can you listen to any changes that occur and send me those events? Okay? So now you're using event concepts within your data and within your systems as well. So this is an inbuilt capability in the Hazelcast product. The ability to listen to all sorts of events, even system events. A new client change or a new member in the cluster has started up. Data is being repartitioned. You can listen to everything that occurs and you have your application react to those events. Okay?
Yeah, careful there. Although if you create lots of those listeners, it'll impact your performance, right?
that is true. Yeah.
That's one of the most important things to consider. That's why you want to use a messaging protocol eventually in this solution. Typically you'll see in the demo, I'm using WebSockets, right? Everyone has some sort of eventing layer in their architecture, especially if you're dealing with companies that have mobile-based applications. So there's always a subsystem that you can actually send those events, forward those events to. So I'm listening on behalf of X number of sessions, and I can know which session is interested in what. I manage that in the service. So it's not a direct connection, or it's a set of sessions that might be interested, that have registered their interest in this particular events. The other thing is, like I mentioned before, is the compute capability. So instead of me grabbing all the products H2O, but and then doing a compute or an average of some attribute on those products, and then that the mobile app requested, I can say, I know this calculation. I want you to send it to the members in the cluster that are hosting these data sets. So you can send compute to specific partitions of data, or you can send compute to specific nodes or the entire cluster. So now this makes your microservice less chatty. What does it do as well?
Do you support collocation of related objects?
Yes, we do. Yeah. So if the
You say I have like order and payments associated with it or something, and I can like make sure that order and related payments are on the same shard or something like that.
Yes. Yeah. So we have collocations, data-aware partitioning that you can associate objects so that they're in the same partition. So if I'm typically computing the average of something for a particular customer, I might put a customer and their orders on the same partition, right? Yeah. And you will. That's literally what we're going to demo. So this is where you get to see what happens now to this microservice, since it's not doing the heavy lifting anymore. And additionally, the heavy lifting is truly sharded across multiple sets of resources. It becomes lighter. The only reason it would have to scale is the number of requests that's coming to it.
A very specific Hazelcast question.
Absolutely.
Well, and it might help people to hear how I'm using Hazelcast. We have a mobile phone app, and on the server side, where the data is stored, I'm load balancing. And if each mobile phone, if it stays on the same IP address, it will stay on the same load balanced server. And if user A is on one load balanced server and user B is on another, what we're using Hazelcast for is just in between the database and the caching on the servers. And we need to, so if server A makes a change, if user A makes a change, user B should know about it in some amount of time, and it doesn't need to be real time. And if it was a minute, that would be fine. And the question there is, if I were to reduce the latency, is there a tuning I could do that would reduce the latency on Hazelcast that would improve my overall performance?
So there's a couple of things in Hazelcast when it comes to listening. You can change how often that happens. You can change the batch sizes of these events that you're sending. So yeah, there are some very low-level tuning capabilities on that. Yeah, yeah.
Yes, for help.
If you're using a map
Listener, for example, to do that, or if you're using, yeah, so a map listener will tell you when an entry changes.
Jay Hipster throws a map listener in the middle.
Yeah. The other thing is, yeah, so if your client, if you need to push that to your mobile app, that change or that event, you can store it. You can say, you know what, I will be the map listener. So my map listener doesn't have to be on my service. It could be written on the server side. And you put it in a queue so that it can be picked up anytime. So it doesn't have to be a direct listener on your service layer. It could be a listener on your service side that says, oh, when someone says, I'm interested in this information, you put the information about who wants to listen and when and what they're listening to, and create message queues that they can go and pull the messages off of.
All the requests have to go through the cache. You wouldn't be able to update database directly because then Hazelcast will have no idea, right?
Yes. So you can. So that's another capability. It's change data capture, where if you change the data information, you can push, Hazelcast can listen to a database and update in place. We have this pattern called evergreen cache to do that. Yeah. So there is, yeah. So when we talk about, oh, I forgot to mention that in one of the pictures. Active in-memory data storage, meaning that it's not static, right? Data may change. Someone changed the data on the system of record, like you said. I need to be able to have active data in memory. So the data in memory needs to reflect what's in the system of record. There are a number of ways you can do that in Hazelcast. If you want it in real time, you can do the change data capture that I mentioned, or near real time. If you want it in a certain amount of time, you can set a time to live for your data, and when the next time someone requests that data, it will go down to the system of record to repopulate the cache. So this idea of having an active in-memory cache is what Hazelcast is about. So we talked about the cache side, where the actual service would have to connect to the system of record if it's not found in the cache. But what if it's timed out? Now it has to go back to the system of record again. Hazelcast can do that for you. So it's called a read-through to the system of record as well. So I can time data that's in memory using time to live, least recently used algorithms, the amount of memory that I have available or used, number of different configurations to start purging and preventing any kind of memory low situations as well. So yeah, this idea of active caching means, you know, data is changing, not only changing because the users change, it may be in memory for a certain amount of time, and then it's not, and being able to retrieve it, the latest values.
Can you talk about how we handle that, Joe? Like how do you keep it in sync? How do you make sure when you're talking about active cache is only as good as the data, you know, and the hygiene of the data that's in it? How do we keep it in sync?
Yeah. So
the way we keep it in sync is we have two methods. You can clear it out and you can read through. We have something called a map store. There's something called a map store. It's a plugin that you put on your in-memory map, and that plugin knows how to do how to retrieve things from your system of record and bring it into memory as an object. It also knows how to load. You can do a bulk load as well. So I may say, you know, I want to load all my data on the first hit, or a percentage of my data on the first hit, it does that. So it's a map store and map loader interface that it implements and allows you to integrate with your system of record. We also have a concept of connectors to multiple different system of records. We're going to get to that situation here. But the ability to connect to system of records, the ability to pull data in, the ability to connect to those system records and know that the data has changed on that system of record. Those are some of the more advanced capabilities when we talk about Hazelcast being Cache++. Okay? So when we look at the reference architecture for Hazelcast, this is what you see here. So this live data store, these are the use cases. The ability to connect back to data at rest sources and data in motion sources. The ability to listen to these sources and know something has changed and I need to update or remove something from memory. And that frees up the microservices that are serving these solutions up. It frees them up from having to deal with all of that. Simplifies your architecture as well. Because if you think about what you would have to do to be able to have those type of functionality, you would have another layer of Kafka, Kafka broker, listening to that guy and putting events on, and then you have some other process listening to those events and updating your cache if you really wanted to do that. And this.
What are the challenges of running Hazelcast in the cloud, like say in GCP or AWS or something? I remember from working distributed caches before is that the caches hate latency, right? I mean, the cloud always has some latency in it, right? Yeah, you don't want like something like a split brain situation or something.
So yeah, Hazelcast is a cluster of members typically running inside of a pod, or maybe if you have a Java application running embedded in your Java application. And the communication between them, the heartbeats, is very important. That will tell the clusters whether or not a member is still part of the cluster or not. And it won't do any type of fault-tolerant behavior.
Say your pod restarts or something, or will that member come back or something?
Absolutely. So the fault tolerance capability. So what we're talking about now is some of the non-functional things you're gaining with Hazelcast that you as a developer don't have to really think about. And that is fault tolerance. If I were to lose one of these Hazelcast cluster members, did I just lose one third of my data? No. The Hazelcast by default has fault tolerant backups of the primary data on the node sharded across the other nodes. So Hazelcast will automatically recover the backups, make them primary, and create new backups. And this happens transparently. So when we talk about truly scalable compute, not just, oh, I got to run another microservice, but now that request has to be sent and start the whole process over again. Hazelcast says, no, I know you requested XYZ. I'm in the middle of resharding it immediately. It usually takes no more than 3 seconds to do, a 40 terabyte Hazelcast cluster. And your request for that data will be served. It's not, your client is not going to have an issue where you might have to write code for retrying this. This kind of happens in the code by default. Now, there could be clients that turn off the auto retry capability and things, so for some reason they want to do that. They can do that as well. But that is part of the resilience you gain, the consistency and the resilience in Hazelcast. And that resilience also has to do with your compute that you're doing that you send to the cluster. So your compute is also durable and recoverable. We keep snapshot of compute jobs that are running in Hazelcast, and we have backups in memory of those snapshots. Using that snapshotting technique, if a node goes down, the data and the job will continue. And we also have this persistence layer where we can persist those snapshots and the data that's in memory if all your nodes go down. And you can, when you restart the cluster, so if it might be in a pod and they're connected to PVs, you restart the cluster, Hazelcast members will read that PV and restart from the point it left off. So these architectural concerns, these non-functional capabilities, just by using the product in your solution, you are gaining all of those.
Is it only eventual consistency, Joe, or is it, do we have the ability for other types of consistency or just eventual?
Yeah, we have other type of.
It's not eventual consistency. What people usually consider as eventual consistency because it's in memory, it's not. Hazelcast is very consistent out of the box. So we have two types of consistency models. We have data consistency, and we have a very tight consistency model called CP subsystem consistency. There are some in-memory data types. So we're not just a map. We do have other sorts of data types. We have ring buffers. We have atomic longs. We have unique number generators. So your atomic long or your lock, those kind of things you don't want to lose when there's a shutdown, and you want it to be consistent. If multiple nodes are shut down, you can put that under a CP subsystem, which allows you to have a much more stronger consistency algorithm for those data types. So we say cache plus plus plus. Yes, we're doing caching, distributed caching. We are not just caching maps. We're not just using maps as the only distributed structure. We have lists. We have multi-maps. We have ring buffers. We have in-memory message queues, in-memory topics. All of those things. That's part of the caching API. So even that caching box is a little more involved in a typical
Java objects, right?
You clash complex
Java objects, complex C++ objects, complex C# objects, and that all has to do with serialization for disparate type of environments. So we are able to cache complex objects in multiple languages.
On the prior slide, I was surprised that logging wasn't listed.
Oh.
Yeah, that's my fault. But yes, maintenance. So yeah, so logging is there. Security logging, audit logging. All of those things are part of the enterprise version of Hazelcast. So those are the enterprise capabilities. But even in the open source, you get a lot of these basic non-functional capabilities.
How about
Band replication, do you have that too?
That's also, yes, that's also
in the enterprise version of the product. So this geo replication, when we look at the enterprise ready, this is what we're talking about, the ability to switch between using AP data structures and CP data structures that are governed by RAF. Security is an enterprise. Vector search is a new enterprise feature that's in beta. High density memory store. We're a Java product. Obviously, garbage collection is a concern for us. Yes, you can use Azul as well. We run on Azul. So if you want, Hazelcast can manage memory for you and allocate native memory on the machine that it's running on. Geo replication, and we call WAN replication, that's also in the enterprise. That's bidirectional as well, or you can have it one way as well. Yeah, so you can configure it by or two-way replication. Or one-way replication, sorry. Hot restart is the feature I was talking about, where if you lose all the members, hot restart literally means that you're persisting the state of the cluster, the state of your compute, and if you lose every member, you can rehydrate the cache really quickly from this. Obviously, the limit is based on the type of disk you're storing in, if it's a SSD or traditional hard disk, spinning disk, even some IBM products that we can actually store our state on. So the ability to do some of these things enhances these microservices architecture and removes those disadvantages, almost all of them, and or reduces the impact of them on your system. So in-memory is great, but with in-memory without the ability to have these architectural qualities, you're probably building on a house of cards there, but this is what you get with the product. You get some recognition in the press. So this is where we talk about logging. We talked about microservices being hard to monitor. So Hazelcast have a cluster management capability. We have a product, a symbiotic product called a Hazelcast Management Center that can be deployed in the cloud as well, or on your laptop, or VMs. That allows you to see what Hazelcast is doing, all the members, all the metrics, and allows you to integrate with your APM tool. So if you're in the cloud or in a container environment, you may not want to connect to every ephemeral container. You want a single point to go to, grab that metrics, build your dashboard, and alert off of that. So the Management Center is a tool that's part of the product. Yes, Datadog,
App Dynamics, New Relic. Yes. So we expose a Prometheus exporter, integrate with Prometheus, and obviously Grafana with the Grafana template. We expose JMX on the Management Center. That's cluster-wide information. We expose a REST API as well to get those metrics as well. So it gives you a number of integration points in order to fit your environment.
Is it
only SQL, or do you also support other databases?
Yes.
So
MongoDB, we have a MongoDB connector. It's a huge one. Anything with a Java or REST API, you can integrate with Hazelcast. This one. Oh, I missed it. There we go. So yeah, ultra low end-to-end latency. Again, this is where my customers go wrong. It's like, okay, we're using in-memory, so whatever I do in my microservice is going to be fast. And maybe, yeah, it does seem faster, but if you don't use some of the features we're talking about to overcome the disadvantages of microservice, eventually, depending on your use case, depending on the number of load you get on your system, you will start noticing some of the disadvantages of the microservice. If you're still going to do a bunch of gets against Hazelcast, gets and puts, and not use the compute, the data-aware compute, the ability to scale the compute across multiple nodes rather than using your microservice that doesn't have that ability, you're going to miss out on really meeting your SLAs as they become more stringent.
Microservice normally owns its own data, right? So would you recommend each microservice to have its own Hazelcast cluster? Would you recommend some sort of a shared Hazelcast cluster across the microservices? And what's the pattern?
So just summarize some of the use cases: caching, in-memory data grid, meaning in-memory data grid means compute and data distribution. Again, so this is the one we're talking about here. how does Hazelcast support microservices? Sometimes that also involves web session capabilities as well. Where are we here? So, did we not move? No, I'm looking at the wrong thing. Okay. Yeah, so we're going to talk about exactly what you just asked, is how does Hazelcast do that as far as deployment patterns, and what do we recommend, and why. So the key thing, again, it's always a tenet of Hazelcast, is simplicity, right? And so a lot of things are just configurable. And the library of Hazelcast itself is very simple. It's a jar, really. Hazelcast Enterprise jar, Hazelcast jar. That's what Hazelcast is from a developer point of view. It's really an artifact you can import in your project, or if you take a traditional way, you can download the zip file, tar file, and install Hazelcast. You can install Hazelcast using a Helm in Kubernetes or an operator. We have an operator that we provide as well that allows you to build Hazelcast clusters as a service. But the use cases, and this is a question a lot of the developers, yes, microservices usually own their own state. And you can see that you can have an isolated microservice, right? And it can either embed Hazelcast if it's written in Java, or have its own cluster, right? So these topologies are important to support, because I may say, you know, I want to have the most fully isolated microservice implementation, because I don't want my search functionality impacting my shopping cart fulfillment functionality, okay? Submit the shopping cart, search for products. I may want to keep them separate, and I do not want to have any fault or bad actor, or I want to scale this independently than this. So you could have that. And the difference between this and that is simple configuration in the product. So I may be instantiating or talking to a dedicated cluster, or I may be sharing a cluster with other microservices.
What would you want to do with this versus that?
Data size, cost, those kinds of things, yeah. Maintenance issues, those kinds of things. Yeah. So when we say cost, cost can mean if you're using Hazelcast Enterprise.
Seems like it's kind of breaking microservices isolation pattern, right? I mean, something.
No.
Not really, but yes. If you
Take that explicitly, yes. It's not breaking it, because the data it's interested in are all in isolated, distributed data structures within Hazelcast. So your data for that particular service is not, shared with the other microservice necessarily. It doesn't have to be. And you have security capabilities that says only this microservice can access this particular data. So you have role-based access to the data as well that you can configure.
Suppose this one is a little easier to manage. You just have a single cluster.
Well, you're going to need a dev cluster and a prod cluster.
Yeah.
Well, yeah. I mean,
I don't know, Joe. Like some of the customers that we talked to with like on the embedded side, like that one that we talked to that also uses JHipster.
Right.
We have these customers that are using Hazelcast. Have been using Hazelcast. This one I'm talking about is JHipster has been doing it for 6 years, and and when we're talking about like this one is easier to manage, they have it embedded and they don't touch it, and they have it, and it runs really well. And that's one of the reasons, like when you talk about like
they do touch it. This is the problem, right? If I want to change my microservice, right, just the code, now I have to take down Hazelcast and reinstall or update, do my CI pipeline and update my microservice, and then rebuild my service set. If it's decoupled, I can do all that lifecycle stuff, and the Hazelcast data is still accessible to anyone else who wants to use it. right? So it all depends. You really have to understand how isolated you want to be or how specific this microservice is. You may say, hey, you know what? I know this thing doesn't do much, and the data it has, no one else is interested in. And I'll explain that later. But and I know it's never going to scale over three members. And I definitely do not want it being taken down if someone else has to do something. So you have to really be prescriptive, because when it comes to architecture, we also have to keep the cost of the system in mind, right? Even though I have 3 of these, I may still have space for a ton more data. Should I go ahead and buy other infrastructure and put a new cluster on there? You have to weigh the pros and cons for that use case. The other thing that's interesting about Hazelcast is that we have multiple different licensing patterns. So we have a microservice licensing pattern that covers where people have no idea what they're scaling to. And then we have a licensing pattern that's a little cheaper and easier to handle, that's based on the number of members in a cluster. So if you know that, it's never going to grow that big, maybe you can negotiate for a node-based license and keep your costs down. And you're not worried about the sharing of the cluster from your business point of view.
From a maintenance point of view, let's say I have decent excess capacity and I want to bring down 1 shard at midnight once a month, or could I possibly do it never? It would just...
Never is a typical use case. But yeah, people do bring it down. What happens typically so it's usually something infrastructure that brings down a Hazelcast solution, especially if it's we didn't go here, but especially if it's client server topology, right? So that the Hazelcast product itself is running in multiple nodes in a different machine, a set of machines or pods or whatever it is. So your client may go down because of your maintenance, you changed your code, but Hazelcast doesn't have to go down. What happens is, someone decides to repave an instance in K8, right? And that starts taking down 1 pod at a time or whatever it might be. Those are the kinds of things that typically happen. Scheduled shutdown of Hazelcast is actually very unusual. Yeah.
And what if you change your schema, like you add some field or something to your object or something like that? I mean,
schema evolution, that's taken care of by the serialization method you choose, and the default one allows you to evolve and add and change attributes and still have the same objects in memory, old objects and new objects.
You don't have to restart and repopulate your cluster.
You can actually not have any code on the server side at all. Yeah, good question. And as you can see in the client server model, if you're using non-Java, that's really the only one you're left with. And now you can have mixed clients actually going against the cluster if you want to. So I can have my .NET and Python client accessing the exact same data.
What differentiates you from competitors like Coherence and Gemfire?
Yeah. So we're talking about 2 types of caching: simple caching and to be able to do compute. Gemfire, we're more like Gemfire because they do have compute capabilities. We're we have the inbuilt ability to deploy to the cloud. We don't need a third party in order to discover the members in the cluster. So we're more robust. So it's a peer-to-peer network. There's no master-slave situation with the Hazelcast clustering mechanism. And Hazelcast has built-in K8 discovery mechanism, 2 of them, DNS or using the K8 APIs. We have the ability to do cloud native discovery. So if you're running on compute in any of the 3 major clouds, we can use those APIs to discover, clients can discover the cluster and the cluster can discover members. Those are the things that makes us more modern than those solutions that you mentioned. But also feature-wise, the ability to deal with data in motion, events processing, the ability to make calls to ML AI algorithms using GRCP. That's part of the product as well. We also have the ability to do similarity searching with our vector collection in-memory storage object.
MCP capability.
MCP.
Model context protocol.
We're doing it. Yeah. Context, yeah. We do have integration with Feast. So if you're doing compute derived features as data is changing, as activity is happening, for example, with our major credit card, we want to calculate the time between transactions and the location, and adding that to the feature set for the model to determine if it's possible fraud. You can do that live with the active cached compute in there. And again, the reason why you can do that with Hazelcast has to do with the latency, because we're doing it here in the cluster, co-located with the event that just occurred and the customer account information and history. So we talked about having data-aware objects. So related objects are in the same partition. So if my account and my history is together in the same partition, that what we call a entry executor. That entry executor runs and does the new calculation, and it adds to the features, it updates the features, and now that feature can be, now that my information can be sent to the fraud algorithm and get a score for fraud. So really quickly, really low latency. What does that allow me to do? Oh, it allows me to calculate more features. It allows me to run an AI algorithm that it does a deeper dive into the fraud scenarios. So you have more accurate, and you screen out more possible fraud in your system. So that latency literally is saving people millions, hundreds of millions of dollars. It's like, I don't need it that fast. I just need to get my web application, my mobile app data back and forth. But again, to be able to do some of these things, you have to have that ultra low latency design and or a system that enables you to simply add that type of architecture or approach to your application implementation. So the pattern here, again, embedded, I could have each of my, so basically my service is a wrapper that also instantiates Hazelcast. When I say instantiate Hazelcast, especially if it's Java, Hazelcast is just a Java object, a member in memory with the rest of your code. So what does that mean? So 1/3 of the time, the data I'm looking for is local to me in a 3-node cluster. Simplifies the architecture. So if you don't have a lot of money or you're trying to keep costs down for your solution, if I don't have to have 3 tiers of infrastructure, I just embed Hazelcast in my Java web service, and they find each other and cluster together, and they share the data. I know we've been doing Q&A as we go.
Where are we for time?
Doing okay.
Okay, great. So the other thing that we want to talk about is these new type of
architectures that the Hazelcast enables the microservices to be able to do and implement. So event-driven architecture, we're going to talk about that. The technology stacks for implementing event-driven architecture, and an introduction to stream processing platform. Hazelcast is also a stream processing platform. Okay. I think we might skip the lab and just go right to the demo. So event-driven microservice. What is an event-driven microservice? It's simply a microservice that produces and consumes events. Okay? Now, obviously, if I post an event to a microservice, that event is a state. It's a temporary state, and it's something that needs to be dealt with, right? In a larger context. So we're going to compare service-based integration with event-based architecture. Okay. We're going to use this retail domain. And so let's suppose we have an order service which is called by a website to initiate an order. That inventory service, that needs to talk to the payment service as well. Wait, and then there's an inventory service to update. And the total number of items may release items held in session, locate and plan like fulfillment reactions. Do we need to reorder this product? Things like that. And then initiate by calling the shipping service, right? So this is the steps typically. So this is, we're talking earlier about API versus messaging, right? This is what this is about. So the benefits of a messaging approach versus a service-based integration approach, right? So you can see, again, we talk about latency and chattiness, right? And coupling. So you can see how much communications, how much knowledge about the other services that order service has to have. Obviously, there's lookup services and things like that that might be running behind the scenes that it has to use in order to find out where the payments are and communicate to them and the inventory and so forth. But now let's look at an event base, okay? Now, the order service, we talk about payments, right? May still have to do an API-based or service-based approach to payments, okay? Payment systems may or may not have messaging APIs, and they may not want it because of how they want to do payments and make sure that payments is, there is no fraud or how they do compensating transactions and things like that behind the scenes. So they may require an API-based approach to calling payments. So it kind of makes sense. Maybe you want to wait that the charge is approved before going on and sending to the order topic, right? As well. So literally, there are techniques in threading. You can avoid blocking and everything else, but you can still send, once it's accepted, send a message to the order topic in order to, once that payment has been approved and your order service is done, right? So the resources are let go, whatever it's doing. The only thing it has a session with is the payments service. And now your order topic picks up the message. There's obviously the inventory service will be a consumer of that topic. Okay? I hope you can start to see how decoupling is happening and how performance, because of that decoupling, how performance is impacted as well, and resilience. So if that reading of the topic fails, that order, if your topic is durable, it's that order is, your orders are still in there and to be processed. So once your order is placed, now you can do shipping. You can send the shipping information, the shipping event, and the shipping event to send the information on to a shipping topic where obviously the fulfillment process will pick up and notify. So now this is the notification process. Let's go back to the loop and even notify the order service, oh, that order has shipped.
I'm anxious to see the demo. Are we going to get to that soon?
Yes, we'll get to the demo. But basically, how that is enabled in Hazelcast. And the ability of Hazelcast to support not just in-memory storage, but the ability to process data from message brokers, the ability itself to have data messages in memory as well, and the ability to have, in order to deal with compute on events, you need a event processing subsystem. And we have that system, and it's called JET. And what we create, instead of session-based code, we create is what we call pipeline jobs. And these pipeline jobs are listening to those different topics and processing them. In this particular case, it's depicting the topic as a partition topic, and it's concurrently reading those topics, the partitions of those topics. What happens with Hazelcast again, when I read a topic with an order for XYZ product, when I group the events in the topic by that product ID, that event is processed, co-located with that product ID. So now I can join that data and update my data in the same partition. So let's go to my lab. I'm going to start, oh, wrong one, wrong demo. Okay.
Can you enlarge the font a bit?
Sure. Same boat. I'm surprised. Okay, so let me start this guy up. So we're going to demo a couple of things we talked about: auditing, monitoring. So this script, what it does is it starts the Hazelcast cluster. It starts the management center component, which again, which is just a WAR file or jar file, and it's going to populate, load some data on startup. And then I'll start the web services tier, and then I'll start the event, the market simulator of events coming in.
Is this all running on your computer or
This is all running on my laptop, yes. Yeah. So yeah, this is all running on the laptop. So you'll see I'm running 5 Hazelcast members and management center, okay? And the first thing we're going to do is open up the management center. It's a web app. You can see the members, 5. Let me go to the default startup page here. So this is a cluster I just started, Borg, big, orange, or big online retail giant. So you can see your cluster view here. You can see a view of multiple clusters from the single management center if you wanted to. The management center is just a client to the cluster. It's a special client. So you can see your clients here, and it says 0 because it knows this guy is a management center type of client. So the next thing I'm going to do is start the web app and the web services tier of the solution. And this is a Spring Boot based web app and web services. So you can see when the web app services start up, they're connecting to the Hazelcast cluster. They see all the members. Now let's go to here. All right. So now we have data. And what this guy has done, he's using a web service to get the inventory by brand, and he's using a web service to get the inventory by product category. Okay? So this is one of the things. So the summation is done on the cluster. It's not done in the web service. So if I wanted to, I tell it, Hazelcast, you know, I need you to go to every accessory, every woodworking tool. They may be on different machines, right? Or they may be partitioned by the type. It will go out to them and collect all that information and sum it for me. So we have what's called an aggregation API that's built in that you can do. You can do your own API, your own aggregation, your own custom aggregations, your own custom logic when you send it to the cluster. So that is a web service that is returning the inventory state. Now, remember, data is not static, so people are going to be shopping, right? So we're going to start a transaction simulator. Events are starting to happen. So every transaction is an event. When you start viewing the world in a Kappa architecture pattern is when you really realize the power of event-driven. So now, as orders are coming in, all these numbers are changing, right? I don't have to necessarily recalculate them and bring them into my microservice and recalculate and spit them out. This is actually being pushed by the server side to my web service and to my session. And I have JavaScript that's listening to web services topics and updating these panels. The other thing I'm listening to is low stock alert. So Hazelcast literally has a listener that says, oh, using this where clause, I can listen to data on this map. So I'm listening to where orders are less than 20 on hand. And it will pop up an alert here. And this is what we're talking about now. If I can have that event into a queue that's where the fulfillment service is listening and go ahead and decide whether or not to reorder that item. And if there's a back order situation, things like that, resolve that.
Automotive went down, like if it got cut down below, it would automatically
show up. Yeah, it's actually listening to specific items. So yeah, not just the categories in there. So let's look at what we have in the management center, right? And how we manage thing. So now you can see my client. So, okay, why is the management center one-stop shopping for metrics? It can also look at the statistics on the clients connected to it. So I can pull those statistics. I can tell an alert how many clients are connected to the cluster, how much memory that client is using. If the client is using near cache, how effective is that near cache is. Any kind of eviction expiration events, the number of hits that are occurring. All of these metrics are available to you, and you can connect whatever APM tool you want to automatically listen to these and alert on them. Okay. The members themselves, also each of them listed with metrics, uptime, the amount of committed memory, how many we have this slow operation detector you can enable, and it will.
Can I kill one? Yes, we're gonna kill a lot. Watch. Yeah.
So let's go this way. So first let's look at what we.
Rebalance.
Oh yes, that's the.
You stealing my thunder? No. So yeah, you can see. So you can see the member information. The other thing you want to see is the data and how the data is managed. Okay. So let's look at the biggest one, transactions. So you can see the transactions. The primary are being stored, sharded across every member, and it's changing in real time, right? But then there's the backups. They're also sharded. So what happens if I add a new member, right? There's no slowdown in the app, and the way we usually show that is that we can still see the counts moving. So if I go here and I say scale, caps. Oh, where am I? Am I not there? Ah. Trying to erase here. So scale is just going to add one more node, right? And what we're going to see is the redistribution occurring in that. So we should see a 7706 member show up. I'm going to refresh it because I don't have a lot of patience. And you can see the data is resharded, right? Now I'm going to kill that node. So by default, there's one backup, right? So obviously, I can only lose one node at a time. If I had a situation where I needed to lose multiple nodes, I may increase the backup count. By default, the backup is written synchronously. So every performance number you see about Hazelcast, this includes writing a synchronous disparate backup on a different node, okay? And we're still in the single-digit millisecond or lower latency ranges. And my scale down is simply a kill -9. Okay, so it's just killing the PID. I know I'm storing the PIDs on startup, and he just goes and kills them. Okay, and we're all right. So this fault tolerance, the ability to trust in-memory data, is huge, right? The other part about it we talked about is.
Say you have like a GCP region and it has like multiple availability zones, like 3 zones or something. Like, can you configure backups to be like zonal or something?
Okay. Yes.
Okay, so we call it zone aware. So yes, we have zone aware replication for the partitions, for the backup. Sorry. Yes. So it's simpler configuration. Zone aware by default. It's node aware, meaning it knows I'm not going to be on the same. So that's why there's a warning. When I look at the members here, Hazelcast is saying, hey, do you know you're running these things on the same machine? If you lose that machine, you're going to lose data. So it's instance aware now. The other thing is, okay, not just multiple zones, what if I have different regions, right? So that's the geo-replication part of it, right? So now that I've put all this data into the system and I want to start another cluster, so I'm starting another 5 nodes. And, oh, wrong one. Let's go back to the management center. So, and we should see cluster B starts to come up. The management center is kind of the pages poll. So they have different settings on them. But okay. So now I have 5 members. They're in the safe mode. On cluster B, I'm going to check. I should have data. I didn't load any data on them. The data is coming from the other cluster when they started up. I can see that right here. When did you get populated? Okay. And they should be exact same. So how do I know that? So now I have clients that are connected to cluster A, right? What if I kill cluster A? Okay. So let's do that. And the way you can, to see how your application is affected by that is looking at this order count. Because both the transaction simulator and the web services are clients. So they will both fail over transparently to cluster B, because I've set them up to be aware that there's an A and B cluster, and they're using A as the primary. So again, it's a kill. Okay, so what we want to look at, oh, there we go. Where is it? Is you see our apps reconnecting. We should have seen the same thing, and then our transaction simulator is restarting after noticing and moving from cluster A to B. So you can see him here saying, hey, I just connected to cluster B with 5 members. You can see him here saying, I'm trying to reconnect to cluster A because I've lost connection. And I've set it up after 10 seconds after retry in 10 seconds with some
How does the client know to connect to a different cluster? Is like something in client configuration?
Yes, exactly. So in the client configuration, oh, wrong client. Wrong client. Okay. So our client is the dashboard web apps here, and they're using a configuration in the resources template. So I have the connection information for both clusters, and in the XML, I'm setting Borg A and Borg B, one try count, but literally, if you look in Borg A, what he's saying is that, with some back off, I want you to keep trying connecting to this cluster if it fails for 10 seconds. If not, then the failover will take over. So it's not a silly constant retry. You're able to have a back off algorithm that it's using. And it's failing back. And now you say, oh, okay. Now, so this is where there's a couple of things here. Now you have failure in multiple sites, but now you have the ability to do blue-green, right? As well. So now it's running in against cluster B. We can see that in our configuration. Number of clients, again, it's not 2. The other thing that happens is that my web services have listeners to the client, the connection state. And so the connection is it's gonna say, oh, I've just lost communication with the cluster I was connected to before. I have to re-establish all those listeners that I had before as well. So it knows that event has occurred, and here you're getting the stock on hand issues. So now let's say, okay, now we want to bring back cluster A. Whatever we did, maybe it was down for infrastructure reasons.
So when you click reload that button, is that part of your app, or is that just a browser refresh?
This one right here?
There was a little drop. Yeah, that one right there.
Yeah, that is the
Management Center web app. Yeah, that's the management.
So that's more than just the browser refresh.
Yeah, my app
is just this guy. Yeah, that's more than that's yeah. Yeah. So now I have cluster. I should have cluster A back up. Let's look over here. Okay. The one thing I want to do is like, oh, the Hazelcast replication only replicates changes. What if something didn't change? Right? Go ahead. And so last thing is a full sync. I was like, I don't want to think about it. Let me just do a full sync. And that is actually a REST call that tells the replication mechanism to replicate to A. And it uses those configuration that's already configured for the WAN to know exactly the destinations. And now I can kill my B cluster. And see this whole fallback behavior all over again. So fault tolerance, resilience, so this guy, I can reload him, or actually, here he goes. Okay, he's back. So I can see orders are coming in. My order simulator is back to cluster A somewhere. Yeah. Okay. And the real key thing about this is that my data is consistent still. That's the important thing. I still have a consistent count, and I still know my back orders and my inventory situation, even with that disaster. Question? Yeah.
Nasty question.
That's your specialty, Rick.
It is. I try real hard. So if I could run Hazelcast, a Hazelcast node on my phone, would I need microservices at all? And is that a possibility?
It is. Right. If you can run, well,
my Android runs Java,
right.
But my iPhone does not.
Yes, that's the problem. That's why we have Rust.
Yeah.
Android is not exactly Java either, right? I mean,
right. You have to get under the covers to build the jobs. I've done this before. So, yeah, and
what you would be running actually may not be exactly a Hazelcast node, but a Hazelcast client in your phone.
Well, it would be a node. That would be really neat.
Well, you run a client because the client would connect to the cluster.
Client would connect to the cluster. Okay.
So you create a client. We have the concept of a client.
People aren't doing that yet.
They're not doing that. Not with Hazelcast. So yeah, that's why the microservices layer is.
Request.
You want to you want to request that? Okay.
Is it specifically for a mobile device? I mean, we have plenty of IoT, type of use cases. Is it specifically for a phone, or is it for a small, like for it to run?
Well, for my app is a mobile phone app.
Yeah.
Yeah. What you're talking about is we can run
on the edge as well. So you would deploy your Hazelcast members or client in an edge local data center.
Oh, that doesn't make my development easier.
You want to get rid of the server company, just go with all of the
So
phone.
connected cards is a situation
That we use this for. So yeah. But yeah, I've been involved in a situation for a military use case where they want to run the cluster member in the phone or the smart device. Yeah. And then when they reconnect, have the cluster determine which data is the most recent one. Yeah. And join it, and you do that healing. So yeah, you're in the field, your network is not so great. You may want to do something like that as opposed to, yeah, and that's where I had to get that giant jar into to a phone or an Android device. Yeah. But yeah, it's a requested use case, but again, with this pattern, event-driven microservice,
it's outside your.
It's outside the scope of what you were talking about all night.
But if you want,
yeah, but what you're talking about is this, right? I really want to keep the latest data on my phone. If you have an event-driven service, microservice, it will push that event, and your phone can store it locally. Yeah, that's really what killed that pattern. Is being able to do that. I appreciate the patience and the involvement. Any other questions?
Can we wrap things up here?
We'll have a copy of this presentation and a link to the demo code and things like that for anyone who's interested. Definitely get you. I think, did we already do that or send you a copy yet?
You can send it to me or to Mike.
Okay, we'll do that. I made some changes, by the way. So yeah.
And it's all here on YouTube. It's going to stay on YouTube.
There you
so
go.
it's there.
So it's, yeah, the code's in GitHub if you're interested, and it's pretty straightforward. Again, you don't necessarily. This is running open source Hazelcast. You don't really need a license, but if you need one, there's a link to request a trial license as well.
So come to us. I have one question. Joe talked about vector search previously. I don't know, Joe. I don't know if you went into it too much. Is anyone using any type of vector databases or any type of vector search, working with vector embeddings, any type of use cases like that? Is anyone doing that? No?
We're using vectors, but for full text search.
For full text search.
Yeah.
You got it covered?
What's that? Yeah, we do.
We got it covered. Lexical.
It's part of the demo where I'm actually auto completing my search using Hazelcast lexical search against a string of letters against the customer's email address. So it's literally taking whatever you type in, it's right sizing it and applying a like query against it, and it works pretty fast. We do indexing as well, so that was the magic behind that. That's why it's fast. So our indexes are in memory and sharded, so they're not all the index in every node. It's sharded across each member. All right.
Any lingering questions? Any last questions? No? Well, I'm going to thank you so much for coming. You go all the way from Hartford, Connecticut, right?
Yes.
Yeah, thank you.
Insurance capital of
the insurance capital, right, and former site of my son's college experience.
Which is?
Yes,
University of Hartford. Yeah,
cool.
Nice.
Right. Okay, here we are in July 2025. We're going to take a month off unless some great speaker comes and says that they want to speak. But normally we take August off, and we'll see you in September. Thank you so much for watching. We'll see you again soon.